All right, so as we take a look here at questions 30 and 31, again, we're still factoring the trinomial completely, so let's go ahead and write number 30 here off to the side, giving us some room. So 4c squared plus 29cd minus 45d squared. All right, so question 1, is there a GCF here that we can pull out? Doesn't look like it. So question 2, how many terms are we working with? Well, we're working with 3. So that tells us either the scissors method or AC method or factor by trial and error. Let's go ahead and try and set up our table for the scissors method. And if we list our factors of 4, we get 1 and 4, 2 and 2. And factors of 45, we have 1 and 45. 2 doesn't work, 3 and 15, 4 doesn't work, 5 and 9? Excuse me. And I think that might be it. All right, so now that we have our factors, you can, like we've been talking about, start with the factors that are closest together. And 9 times out of 10, if you start with the factors that are closest together, you should be able to find a combination that works for you. Except, I'm looking at these, and just because, again, I've done so many of these, and you will get to this point too by test day, I hope, after you've done so many problems from your homework and this practice test, and hopefully some extra credit opportunities. You will have done so many of these, you will start to recognize what factors work, and I'm looking at these and I don't think we're going to find any factors that are going to give us something that we can work with, and so I'm starting to think this might be a prime expression. So let's see here, because if we try, let's see, 2 times 9, well, that gives us 18, 2 times 5, well, that gives us 10. Can we in some combination subtract 10 and 18 or 18 and 10 to get positive 29? No, that's not going to work. So we can try now 2 times 5, well, that gives us 10. 2 times 8 gives us 18. Can we subtract 10 and 18 or 18 and 10 in some combination to get positive 29? No, that's not going to work. So if we try 2 and 2 and 3 and 15, well, let's see. 2 times 15 gives us 30. 2 times 3 gives us 6. So a 30 and a 6, can we somehow get a positive 29 out of? No. And so we can try 2 and 45 gives us 90. 2 times 1 gives us 2. So we have a 90 and a 2. Can we get a 29 out of those? No. And then you can go through and try your 1 and 4 with each of these combinations. But again, I don't think you're going to be able to find anything. And when that's the case, when you're not able to find any factors that work for you in order to get, what it is that you're looking for, if it can't be factored, then it's considered a prime trinomial, and so there's just nothing you can do. You can't break this down any further. This is already in simplest terms, and so you write prime and you move on. All right, let's take a look here at 31. So we have 2x squared minus 6xy minus 8y squared. Again, let's go ahead and ask ourselves that first question, is there a GCF here that we can take out? Looks like there is, right? We can pull out a 2, and when we do, we're left with x squared minus 3xy minus 4y squared. And now that we've factored out a 2, we have a trinomial left. So again, that's 3 terms. So that second question, how many terms are there? That tells us what method of factoring to use. With 3 terms, you scissors or AC or trial and error. And this is actually not too bad, right? Because if you remember from the very beginning of this trinomial section, we talked about when the coefficient in front of your x squared term or your square term is 1, the factoring becomes pretty easy. You can straight away go ahead and create 2 sets of empty parentheses. We are working with an x, so we have our x is going to be at the beginning. And now we're looking for factors of 4 that subtract to give us negative 3. Well, factors of 4 are 1 and 4, 2 and 2. we want to subtract to get negative 3. So we can't use a 2 and 2, so we're definitely going to be using 1 and 4. All right, and how about we make the 1 a positive and the 4 a negative, right? Because 1 minus 4 gives us negative 3. So we have x plus 1, x minus 4, and there we have it. We have our factored form of number 31. And again, you can double check yourself and multiply these together to make sure you get back to your original expression. And it doesn't matter which order you multiply in, so long as you get back the original expression. So let's go ahead and try this. And generally speaking, I always will FOIL my two binomials together, and then whatever that result is, I'll then distribute a 2 through, and hopefully we get what we started with. So let's try that. Let's go ahead and FOIL these two binomials together. And when we do that, we have x times x, so that gives us x squared, x times negative 4, so that's minus 4x, and then 1 times x, well, that's just x, and then 1 times negative 4 is negative 4. Let's go ahead and combine like terms, so we end up with x squared minus 3x minus 4. And, oh, you know what I did here? We have a trinomial. I forgot to add the y here at the end, right? Because we have an x at the beginning of our trinomial, so this x and this x, but we have a y squared here at the end, don't we? So I need to add my y at the end. That was my mistake. All right, so let's go ahead and compensate for that. So let's get rid of this. I'll just start over again. All right, so we had x times x gives us x squared, and now x times negative 4y gives us minus 4xy, and now 1y, and we don't really have to write that 1 there, right? We can just say y, so let's go ahead and make it a little bigger, y. Y times x, well, that gives us a plus xy, and y times negative 4y gives us minus 4y squared. Now when we combine like terms, we end up with x squared minus 3xy minus 4y squared. So that is the result of multiplying our two binomials together, foiling them together. So now let's go ahead and distribute this 2 through the trinomial. And let's see, 2 times x squared, 2x squared, 2 times negative 3xy is negative 6xy, and 2 times negative 4y squared gives us negative 8y squared, and hopefully this, let's see, does that match what we started with? It sure does. So we know that we factored this trinomial correctly. All right, let's take a look at the next set of questions in our upcoming video. This is Joe Brownlee with Palm Beach State. Thanks for watching.